Chaji, we'll be covering trigonometry of 3D shapes and we will cover around 6 of these questions in this video. I'll try to be quick to make it short. So, okay, question number 1. In the figure, triangle ABC is a right angle at C. So, get familiar with this shape as right angle at C and laying a horizontal plane P is the point vertically above C and AC is 7 marked already, BC is 6 it is marked, and AP is 11 that is also marked. Calculate PC. Now look at this. For calculating PC I am using this right angled triangle and it is 11 square using Pythagoras theorem is equals to 7 square plus PC square. So PC is equals to 11 square minus 7 square whole square root, and the answer is 11 square minus 7 square, that is square root 72, which is 8.5 centimeters rounded to 1 decimal place. Second part says find angle PAC. For PAC, you need to find this angle. I am going for cos. So cos of PAC is base over hypotenuse. So PAC is cos inverse of 7 by 11. And the answer is 50.5 degrees, again at 1 decimal place. Third says the angle of elevation. For angle of elevation, it is the angle when you look above the horizontal. If he would have asked for angle of depression, that would have been angle below the horizontal. So only for the angle of elevation we move up from the horizontal, which is angle of elevation of P from B. So from B, this is the angle to look at P, and we can use this perpendicular and base. So tan of B is perpendicular over base. So B is equals to tan inverse 8.5 by 6, and the angle of elevation is 54.8 degrees rounded to 1 decimal place. Question number 2. A, B and C are 3 points on level ground. This is A, this is B, this is C on level ground. BD is vertical and a vertical flagpole of height 12 centimeters. 12 meters, right? So these lengths are in meters. So given that DAB is 35, DAB, this angle right here is 35, ABC is 90 degrees, and AC is 24. AC is 24. So get used with this diagram. And then it says calculate AB. Okay. So to calculate this AB, I'm using this complete triangle, and you see I have this perpendicular, I'm using this base and 35. So tan of 35 is perpendicular over base. So AB is 12 over tan 35, and AB is 12 divided by tan 35, which is 17.13, and approximately equal to 17.1 meter. The diagram is not to scale. Then BC, if I have to find BC, I can use Pythagoras theorem. So using the triangle at the base, this is 24, this is 17.1, this is unknown. So 24 square using Pythagoras theorem is equals to 17.1 square plus x square. Solving for x, you get 24 square minus 17.1 square whole under the root is 24 square minus 17.1 squared, and square root answer it is 16.84. So we're done with AB, we're done with BC, Last part says angle of elevation of D from C. So we know that this length was 16.84. Angle of elevation is this right here. So you use tan again. So tan of C is perpendicular over base. So C is equals to tan inverse of 12 by 16.84. Shift tan 12 divided by 16.84 and your angle is 35.5 degrees. Coming on to question number 3. A rectangular box has a horizontal base of EFGH, has a horizontal base EFGH, and the corner D is vertically above H, below H. Surely, given that DH is 4, so DH is 4 and HG is 6, HG is 6 as of AB, and GF is 8, GF is 8 as it is in case of AD. So calculate DGH. This is D, this is G, this is H. If we have to calculate this angle right here, I'm using tan. So tan of G is perpendicular over base, 4 over 6. So angle G is tan inverse of 4 by 6, which is 33.7 degrees. Second part says find HF. H is here and F is here. So if we draw this, it is a rectangle at 90 degree at G. So this makes it hypotenuse. So HF squared is equals to 6 square plus 8 square. So HF is square root 6 square plus 8 square. That is 10 centimeters. So HF is 10 centimeters. Last part is DFH. So D, this is D, this is F, this is H. So if we have to find this angle, I already know that FH is 10 and HD is 4. So we can find this angle by using tan again. So tan of F is equals to perpendicular over base. So F is equals to tan inverse 4 by 10 is 21.8 degrees. Moving on to question number 4. The diagram shows the rectangular box in which AB is equals to 3. Okay, this is AB, that is 3. AD is 4 and DH is 12. This vertical height is 12. Find the length of BD and BH. BD, BH. So this is B, this is D. So for BD, we use Pythagoras theorem. BD squared is equals to 3 square plus 4 square. BD being the hypotenuse and longest side, BD comes out to be 5 centimeter. For BH, if you look at BHD, this triangle, if you look at BHD, so BH is now the hypotenuse. So BH squared is equals to base. One is 5, the other side is 12. So BH is equals to square root 25 plus 1, 44. And your answer is 13. So this was 5 and this is 13. We'll use these values later. Now it says BDC, angle BDC. So for BDC, if I can extract this triangle, BD is 5, DC is 3. So BDC, this angle, we can use cos. So cos of D is base over hypotenuse. So this angle will be cos inverse. BDC would be cos inverse of 3 by 5, which is 53.1 degrees. Second angle is HBD. HBD. We already have all three sides, so you can use sine, cos, tan, anything you wish. I'm going for sine. Sine of HBD is perpendicular over hypotenuse. So angle HBD is equals to sine inverse of 12 by 13. And your answer is 67.4 degrees, rounded to one decimal place. Question number 5. The diagram shows the rectangular box in which has a horizontal base of A, B, C, D, where AB is 8, this is 8, BC is 15, complete length 15, and BF is equals to 7, height is 7. X is a point on AD such that XD is 4. If this is 4, we know that this part will be 11. So X is the point which is 4. Calculate CEG. So C, and this is E, and this is G. To find this angle CEG, we will be using two things. I know this length is 15, EC. For EC, you need to find the length, which is 15 squared plus 7 squared plus 8 square whole under the root. You can first find CF and then again apply Pythagoras theorem to this, but if you are given 3 dimensions, this will work. This formula leaves the answer of the diagonal length. So 15 squared plus 7 squared plus 8 squared, that is 338, and square root of answer is 13 square root 2, which is 18.38. So I know the length of CE, that is 18.38. Now I need the length of EG. So EG squared is equals to 8 square plus 15 square, Pythagoras theorem. So EG is equals to square root of 8 square plus 15 square, that is a perfect 17. Now you extract this triangle out. So we know this height was 7, this is E, this is G, this is C, CG was 7, CE was 18.38, I'm writing 18.4, and EG is 17. The unknown angle is CEG. This is the unknown angle, so go for cos. So cos of E is, you start with these two, 17 square plus 8.4 square minus 7 square divided by 2 times 17 times 18.4. So cos of E is, use your machines and check the answer with me, 17 square plus 18.4 squared minus 7 square over 2 times 17 times 18.4, which is 0.9284, and cos inverse of this, you get an angle of 23.4 degrees. So this angle right here is 22.4 degrees. Next angle is GXH. So GXH. Again, to find this, we need these lengths. We already know GH is 8. So GX, I'm using the same formula. GX is equals to, one length involved is from G to C is 7 square, from C to AD is 8 square, from D to X is 4 square, whole square root. So that is 7 square plus 8 square plus 4 square, 129, and square root of answer is 11.35. So GX is 11.35. And for HX is a Pythagoras theorem, hypotenuse. This is 4 squared plus 7 squared. So HX is equals to square root 4 square plus 7 square, which is square root 65, and that is 8.06. So 8.1. Again, extract the triangle. This is G, this is H, this is X. GX is 11.35. This is 8, and X 11 is 8.1. So we need to find this angle. Again, use cos. So cos of x, cos rule, is 11.35 square plus 8.1 square minus 8 square over 2 times 11.35 times 8.1. So cos of x, using the calculator, 11.35 squared plus 8.1 square minus 8 square divided by 2 times 11.35 times 8.1. It is 0.709. So cos inverse of your answer, the angle is 44.8 degrees. Coming to the last question of this video, question number 6. In the diagram, PZ is vertical and XYZ is an equilateral triangle. So if this is equilateral, this length at the back is 6, this complete is 6. Laying on the horizontal plane, PX is equals to PY, PX, PY, and already labeled 10, and R is the midpoint. If this is the midpoint, it is 3, and this is also 3. Okay, what do we need to calculate is PYZ. So this is P, this is Y, this is Z. So for angle PYZ, bring out this triangle. This is 10, this is 6. You need to solve for this angle. So use cos. So cos of y is base over hypotenuse, and base y is cos inverse 6 by 10. And your angle is 53.1 degrees. Second part says PRZ. This is P, this is R, this is Z. So PRZ. In order to get this, we need few values, any of these. So if I solve for ZR, I know that this is 60 degrees. First, let us solve for PZ, because we already know this is 10 and this is 6. So PY is 10 and this is 6. So solving for this, that is 10 square minus 6 square whole square root, that is 8. So height is 8, and we know that this is 60. If it is 60 degrees, this is 6, this is 3. So you can actually find the length of ZR using cos rule. So let me call it x. So that is x square is equals to 6 square plus 3 square minus 2 into 6 into 3 into cos of 60. So x square is equals to, if you cannot use this directly, please go to the video, I have uploaded it, labeled cos rule. So this is 6 square plus 3 square minus 2 into 6 into 3 into cos of 60, that is 27, and x is equals to square root of 27. So now we have the length ZR, which is square root 27, 5.2. In order to get the angle PZR, you can now use tan. So tan of PRZ is equals to perpendicular over base. So PRZ is equals to tan inverse of 8 and 5.2, which is 56.97, approximately equal to 57.0 degrees. Thank you so much. Take care. Allah Hafiz.